We're pleased to present this video, which represents a variety of pipeline cleaning projects utilizing our flexible polyurethane foam cleaning devices, referred to as pipepigs. Pipepigs have been around for over 30 years and have been used to maintain pipeline efficiency in industries ranging from oil and gas, fresh water, wastewater, power plants, pulp and paper mills, manufacturing, refinery, chemical plants, mining, food process, and new construction. The design allows the polypig to form a tight seal in the line and is most often propelled by existing line pressure and volume. When adequate pressure and volume are applied behind the pig, it forms a sliding seal as it negotiates the length of the line. The flexible foam body and tough polyurethane coating of the pig allows for negotiation of short radius bends, reduced port valves, and even multi-dimensional piping and tees. We manufacture over 30 types of polypigs ranging from below 2 inches to over 66 inches in diameter, for service ranging from light-duty swabs for sweeping loose debris and drying to heavy scraping units for removing tough scale deposits. Now let's take a look at the product in action. In preparation for the cleaning process, the section to be cleaned is first isolated and entry and exit points are determined. This application allows for pigs to enter and exit through existing fire hydrants. The valve and stem assembly are first removed, and an oversized launcher is bolted or flanged to the hydrant to ease the insertion of the pigs. The water is then turned on to double-check the direction of flow at the exit point. This 6-inch cast iron potable water main was experiencing discolored water and low flows. The first pig to be run is a soft 2-pound density foam swab, which is used to prove the line integrity and to remove loose debris not yet adhered to the pipe wall. As the swab approaches the exit point, the loose sediment and debris darken the water. Continuing the progressive pigging process, where each pig paves the way for the next, we progress to a slightly tougher 5-pound density bare foam pig, which allows for further cleaning of the line while providing the operator with an internal gauge of the line conditions upon the exit. Again, as the pig approaches the exit point, even more scale and debris are removed from the pipe wall. The next pig run is a 5-pound density crisscross coated pig which has tough polyurethane spirals adhered to the surface of the foam. These spirals expand against the pipe wall to further dislodge the tough scale deposits. Depending on the scale thickness and hardness, several crisscross coated pigs may be necessary. As the crisscross coated pig approaches the exit point, again even heavier deposits and debris darken the water. Because of extra hard scale deposits close to the pipe wall, this line also required a wire brush type pig to be run. Similar in construction to the 5-pound density crisscross coated pig, the wire brush pig has flame hardened carbon steel wire brush strips adhered to the foam body. The spiral pattern of the wire allows for full pipe coverage while maintaining flexibility to negotiate the various piping configurations. The wire brush pig, followed by a swab for sweeping, removes the remaining hard-scale deposit and debris. Even though the pigs have had a tough journey, they exit in relatively good condition, as this full series indicates. A final swab run is a good idea for sweeping any remaining debris and for comparison to the initial swab run. To summarize, the project consisted of cleaning approximately 2,800 feet of 6-inch cast iron potable water line. The primary purpose for cleaning was to remove foreign matter and manganese causing quality complaints. The pigs entered and exited through existing fire hydrants. All pigs were required to negotiate several 90-degree bends and tees. Service was only interrupted for approximately 2 hours. The benefits included increased flow by removing restricting deposits, improved water quality, and lower pump pressure. The scale and mineral deposits removed from this potable water line were retained in a filter bag to further demonstrate the amount of debris being dislodged and removed with the progressive pigging method. This 10-inch potable water line was experiencing extreme low flow due to an accumulation of scale deposits on the pipe wall. Although the buildup was relatively thin, the irregular nature of the deposits over the 4-mile pipe section was enough to severely reduce the flow capacity and increase the pump pressure. Project engineers made a thorough study of the 7-year-old line to review the line construction and design details and a full analysis of the pump and impeller efficiency. When the decision was finally made to pig the line, the amount of debris removed was astounding to everyone. Needless to say, the pigs removed the flow-restricting deposits to restore the line capacity to near new characteristics. To summarize, the length of pipe, approximately 4 miles of potable water line. The primary purpose of cleaning was to remove flow-restricting deposits. Entry point through an installed T-section with exit from open-ended pipe. Pigs negotiated various pipe fittings, including valves, elbows, T's, and service connections. Total pigging time required was only 4 hours. Benefits included increased flow, lower pump pressure, improved water quality, confirmed pipe and flow integrity, and canceled consideration for new line construction. This 70-inch diameter special combination foam disc pig was designed and constructed and utilized within 3 weeks from the project conception. The 30-mile-long concrete aqueduct carrying raw water was experiencing unsatisfactory flow rates as a result of an organic buildup on the pipe wall. Pig entry and exit were achieved by utilizing existing open-channel vaults on the pipe. Before the pig was lowered into the vault, the electronic pig tracking device was activated. As water slowly rises behind the pig and head pressure increases, the pig begins the 30-mile journey. The pig's exit required a specially engineered ramp to be placed in the final retrieval vault. The ramp design allowed the pig to exit without interrupting normal flow to the treatment plant. The pigging process was a complete success, increasing the flow capacity by a substantial margin. To summarize, 30 miles of 69-inch concrete cylinder pipe was cleaned. The primary purpose of pigging was to increase flow capacity. Pig entry and exit were made through existing vaults. The pigs negotiated several 1.5-mile tunnels through the mountains. Among the benefits were increased flow capacity. Project from conception to completion was accomplished in a short period of time, required no piping additions or modifications by the owner. Overall project cost yielded low-cost cleaning. Cross-country oil and gas-related pipelines often require a special level of cleaning to remove rust and mill scale from the new pipe. After hydrostatic testing, the bulk of the test water is removed. Then light swabs are run through to absorb any remaining water. When all remaining water has been removed, wire brush pigs are run to remove the rust and mill scale. Finally, additional swabs are run to sweep out the loosened rust and mill scale from the pipe. Depending on the product and customer requirements, pigging new pipelines can range from running a few pigs for water removal to large numbers of runs to achieve specific dew point requirements. In plant and refinery applications, customer requirements often result in the use of a special filter bag. This application allowed for pigs to exit a special receiver while the filter bag captured the fine particles of rust and scale. This 12-inch potable water pipeline was experiencing discolored water due to iron oxide deposits on the pipe wall. Residents along the pipe route were complaining to district officials even after an aggressive flushing program was put into place. Light 2-pound density swabs were launched directly into existing fire hydrants, which had the stem and valve assembly removed. An auxiliary pump was used to propel the swabs through the hydrant barrel and into the main line. Once in the main line, the auxiliary pump was shut off and the main line valve was opened, allowing the line pressure and volume to propel the pig to the exit point. Over the 3,000-foot run, the swabs removed the iron oxide deposits by wiping the pipe wall for efficient removal. A similar situation required the pigs to remove manganese from the pipe wall, which had created a severe water quality problem. A total of 3 swabs were run through each pipe section to remove the manganese and other loose debris. The condition of the pig upon exit is always a good indicator of the internal pipe conditions. Within a very short period of time, the water was restored to the residents, and the quality of the water was greatly improved. We hope you found this short overview of pipeline pigging of interest. With all of the pipe cleaning options available in the marketplace today, this safe, proven, economical method stands out. We'd like an opportunity to put our 50 years of combined pigging experience and know-how to work for you. Please contact us for the name of the stocking distributor and/or cleaning service company nearest you.
You may reach us by phone 281-351-6688 or 1-800-242-7997. We appreciate your consideration.